Infinity here. So today we are going to discuss the locker room problem. Here is the problem. A school has 500 lockers numbered 1 to 500. The first student opens all the lockers. The second student closes every second locker. The third closes every third locker if it was open and opens every third locker if it was closed, and so on. With each of the 500 students doing this, how many lockers will remain open after all 500 students have had a turn? You can pause here to give this problem a try. Let's go to the solution now. So let's take smaller number of lockers and students. Here we are taking 5. So in this case, student number 1 will open all 1 to 5 lockers. Student number 2 will close locker number 2 and locker number 4. Student number 3 will close locker number 3. Student number 4 will open locker number 4. And student number 5 will close locker number 5. Locker numbers 1 and 4 are the ones that remain open. But why? Let's look at exactly which lockers are touched by which students. We know that locker number 2 had been touched by student number 1 and 2. Let's take another example, another number, bigger number. So locker number 10 will be touched by student number 1, 2, 5 and 10. Moving to another number, locker number 16 will be touched by student number 1, 2, 4, 8 and 16. So here again you can see that 16 has 5 factors because 16 has a special factor which is 4, which is multiplying with itself to form 16. So here is a pattern. Locker number 2 have even number of factors. Number 10 also have even number of factors. But number 16 has odd number of factors. Why? It's a perfect square of 4. So here we conclude that square numbers and only square numbers have an odd number of factors. Now let's see that how the number of factors of lockers will affect the locker status. Here we see that if a locker has even number of factors, then the locker status will be closed. If the locker has odd number of factors, then the locker status will be open. And as we have already seen, only perfect squares have an odd number of factors. So only lockers which are perfect squares will remain open. So now all we have to find is how many perfect squares are there from 1 to 500. We'll see that square of 20 is 400, square of 21 is 441, square of 22 is 484. So square of 23, which is 529, is going beyond 500. So we'll not take this and we'll just take square of 22, which is 484, and it comes within the range of 500. Which means that 22 lockers will remain open after all 500 students have had a turn. Now we have a question for you also, in which you have to find out that what is the sum of all the lockers which will remain closed after all 500 students have had a turn. So if you get the answer, then please write in the comments. Please like and subscribe.